In this video, I'll talk about exploratory data analysis. Exploratory data analysis is in short known as EDA. EDA is a must process before you do any statistical analysis. So what is exploratory data analysis? Going by the wording. Exploratory, that means we need to explore something. So what do we explore? We explore the data, and that's the reason why we call it as exploratory data and analysis. So before any statistical analysis, we need to do some analysis on the data set to have some idea about the data, so that it will help us.
The people at the top earning the most money know something you don't. Think about it. How could someone earn 10 times, 50 times, 100 times what you do while working from anywhere, living life on their own terms? Not reporting to an incompetent boss or sitting in rush hour traffic. It's simply because there are secrets at the top that the rich don't want you to know. It's Christian Martin here, 7-figure business owner, 2 Comma Club winner, and world traveler. And if you think about your ability to earn money, you must understand that what you've been taught in school has kept you completely poor. There's a reason we call a job just over broke. That's about all you can do with it. I mean, you can save up for 60 years, but then you're almost too old to even do anything with your money. And I don't know about you, but I want to enjoy my money now. But think about it. Do the people at the top producers, the people earning 6 and 7 figures, work 100 times harder than you do? Probably not. That's impossible. I bet you work pretty hard. It turns out the amount of money you earn isn't tied to how hard you work at all. But do the people at the top have a better network, or are they born with a silver spoon? It's also a common lie in society that you can't get ahead unless you are born into money. It's simply not true. This is Cody. He went from a barista to making $30K profit in a week. This is Chad. He went from being a personal trainer to making $7,000 in one day. This is Charmaine. She doubled her full-time salary her first week in business and stopped reporting to a boss. The reason these people make so much money and you don't is they simply know things that you do not. They understand how money works in the new economy, because they watched the free training on the other side of this ad. They all started there. It was the portal into a new world, the event that took them from job to earning what they want on their own time from their own homes. No rush hour commute, no incompetent bosses, no high society network or trust fund to back them up. Just normal people who took it on themselves to say, I'm actually, for once, going to put away Instagram, close Facebook, and concentrate on learning for an hour, because it will change my life. Because let me be very clear. If you cannot take 1 hour to learn how money works in the new economy, how to change your income forever, you will never be rich. If the best you can get yourself to do is enter your email and then not actually show up to a training, you will never make it. You'll be stuck scrolling Instagram, staying broke, and blaming it on It's All About Who You Know or Those People Have It Better Off Than Me. I can tell you they don't. They're just normal people who watched this training and learned how to generate money on demand using something I call online sign spinning. It's a new service you can start offering to paying clients today, a service that has absolutely blown up since demand for online goods has skyrocketed this year. The only thing is, money loves speed. Now is the time. So you have to get in while the getting's still good. If you want to come learn how money works in the new economy, how Chad, Cody, and Charmaine all blew up their income just from watching this training, click through now and enter your best email. And here's the kicker. Actually show up to the training. We're going to get you results on this training absolutely free. Or don't show up. Just don't blame rich people when you can't earn what you want. Blame your attention span. Click through, enter your email, and I'll see you on the training.
If you are struggling to grow your coaching business, you must stop doing one-to-one sessions. It is throttling the growth of your business. Let me explain. There are three main reasons why, if you want to grow and scale your coaching business, one-to-ones make absolutely no sense. The first reason is it's not a scalable model. There are only so many hours in the day, and you are trading.
Doing modeling exercise in a better way. So to do that, let's take a test data set. We have so many test data sets in the library SAS help. Go to Explorer, then SAS help. You can see the dataset car. We'll take that, and we'll do exploration on that, or exploratory data analysis on that. So first we will get the datasets from SAS help. SAS help is a library where you have a lot of test datasets. So we'll take the data cards from there to the work library. As you know, SAS has got permanent library and temporary library. So SAS help is a permanent library, and we are taking the dataset cards from this permanent library to the temporary library. So temporary library is nothing but your work library. Okay. So we will run this code first, this data statement, wherein we are importing the data from the SAS help to the work library. To see whether the import is successful or not, go to your work library, and it says that it's not there. The data set is not there. So something is wrong. Okay. So it's not run properly. Okay. Yes. Now we can see the dataset cards is there in the work library. So the import is successful. Okay. When we have the data, the very first thing that we should be doing is that to open the datasets. To do that, you double click on the dataset, and you will see what all variables are there and how the dataset look like. So the dataset is having variables related to the cars. You have make of the car, model of the car, type, origin, and then many other variables like horsepower, engine size, weight, length. So how many observations are there? If you drag it below, you will see that total 420 observations are there. Okay. And how many variables are there? So in the top of the data set, you have the first row has the variables, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in total you have 15 variables and 428 observations. We can do it better. You don't have to go to the data set and count the variables and then take a note of what are the variables are. We can use prop contents, and we can do it very easily. So let's run prop content on that. So the syntax is like this: prop contents data, and then you give the name of the data set, and then run it. Go to the output window, and you can
With HelloFresh, picking recipes never gets old.
She loves it too.
Her paws don't work, but we don't tell her. She's here! With step.
see. Now you have the details about the dataset. So our dataset name is walk.cars. So walk is the library and cars is the name of the dataset. Okay. So when is it created? You have the date. You have the operating system where it is created. You have the number of observations, so you don't have to scroll it down and see what is the number of observations. Prop contents gives you the details. You have 428 observations. How many variables are there? 15 variables. We counted 15, right? So the system counts it for you, so you don't have to do it by yourself. Whether the data is compressed or sorted, no, it says that it's not sorted. And then you have the path where this data is stored. Down below, you can see the number of variables, the variable names, as well as their the format, the type, and the level. So you have the variable names here, and then type of the variable, whether it's a numerical variable or it's a character variable or it's a date variable. So NUM stands for numerical variable, CHAR stands for character variable. So what is the difference? Numerical variables has numbers like length, weight, that kind of variable. Whereas character variable will have variables like make of the car, non-quantitative variables which cannot be quantified, like model, make, the type of the car or the origin of the car. These are the variables. And then you have variable length here. Okay, so you can change the length later on. And then you have the format. If it is blank, then the default format is there. Then there is variable level. Not all the variables has got labels. You can always have labels later on. So in the dataset, there are few variables where you have the label. So what is the label? So label is an alternative name of the variable. Okay. So if a variable has a label, so when you see the dataset, your actual variable name will not be shown there. Your label name only be shown there. Why is it done? Say let's see, for example, you have engine size, right? So engine and size, they are just one word. Okay, there is no space between engine and size. If you have a space between them, it will not be considered as a variable name. Okay, so you cannot have a name of the variable having a space, blank space inside two words. That's not allowed in SAS. But how do we interpret? How do a non-statistician who doesn't know SAS or who is a statistician but is not using SAS, how will he get to know what this variable means? Well, for that we use a different name, an alternative name, easier to understand, and that's the reason why we have like engine, then we have put a space there, and then size. So it's easily understandable, right? Similarly, you can see MPG city. Okay, so what does that mean? Probably we don't know. So we have a detail or a better name for that, and we have given that. So that's the reason why we use label. Not necessarily we need to have labels for everything. It's an optional. If it is clearly understood, if the variable name is clearly understood, there is no reason why we should have a label there. Okay. So that's about prog content. So what is the use of prog content? If you want to see what all things are there in the data set, you need to use prog content. And that's the first thing one need to do when somebody gets a data set. Okay. So what if you want to save, or you want to have the details about the data in another data set? Okay, so you just want to have the type and then the name of the variables, total number of observations, all that in a separate data set. Okay, so for that, same syntax, you just have to use the out state lib will be saved in the lib library. Okay, but we don't have any library as such, so it will be saved with the default library, which is the work library. So let's run this. Yes, it's successful. So as you can see, in the work library, car underscore details is saved. Let's open this. So we can see that you have the name of the library, then the variable names, variable types. So what does that 1 and 2 mean? So you need to check whether 1 is numeric or 2 is numeric. You can decode it also later on. And then total number of observations, date modify. So the details about the data set is now saved in another data set. Okay, you might need it in later point of time. What we need, sometime is the number of variables and the name of the variables. Okay, so you just have to run this code and get the variable name saved in another data set. And it's very useful when you want to loop all your variables in a program, or you want to do something about it. So you will find it very useful there. Okay, so the next thing is that we'll do variable exploration with proc means. So what all things can we do using proc means? Okay, so the syntax is like this. Proc means data, your data name, and then use the keyword var, and then put a variable name. For simplicity purpose, I have used only one variable name. Okay, you can use all the variables name at one time. At one go you can put all the variable names. Remember, in proc means you can use only the numeric variables. You can use character variables, but interpreting character variables in terms of its means, it's very difficult. So generally we use only the numeric variables in the proc means. So let's run this. So when we run this, we have the following. The proc means gives us, the first thing is your n, which is the count of observations, 428. Then the mean length. So what is a mean? Mean is nothing but your average, sum of the total or sum of all the observations by the number of observations. And then we have the standard deviation here, minimum value and the maximum value. So minimum value of length and the maximum value of length in the data set. Okay, so these values or these statistics are very important in many aspects. So before doing any statistical modeling, it's very important that we know what is the mean of the data, what is the standard deviation of the data, what is the minimum value and what is the maximum value. So how is it going to help us? Say for example, the minimum value is 0. Okay. Do you think that the length of a car can ever be 0? Well, it cannot. So there must be some error in the data set, and we can just go and check it out. So sometimes the data might look very suspicious, and we need to go back and check whether the data, and then we need to consult the company or the organization from where we have received our data set. Same thing about maximum value. If the maximum value is too high, say for example 500 meter, it's very unlikely you have a 500 unit. Very unlikely you'll have that kind of a length of a car. So this really helps us knowing knowing the characteristics of the data set. So you might have heard about outliers. So what are the outliers? Outliers are the ones or the observations which are very different from the usual observation or the normal observations. Okay, they're very far apart. In statistical modeling, it is very difficult to model the data when you have outliers. So how do you know whether you have outliers in the data? One way of knowing whether you have outliers in the data set is to first see the mean, standard deviation and minimum maximum. If you have a very high value in the maximum, probably that will be an outlier. A very minimum value, probably that observation can be taken as an outlier. Similarly, mean and standard deviation can also help. For example, if the mean is less and the standard deviation is quite high, that means there is a serious deviations from the mean value. Okay, that means some of the observations are at a very large distance from the mean. You expect that most of the observations will be located nearby the means, not very far away from the mean. So high standard deviation is one way, or one way in which you will get to know that there is possibility of having outlier. And you can confirm it by doing other type of exploratory data analysis, which we will study, and then you can take appropriate measure in dealing with this problem. So how do we deal with outliers? We will study that in another lecture. But this is the way you will get to know the characteristics of a numeric variable. So as I said in the beginning, you can do it for n number of variables. So you may have as many number of variables, and you can do the explorations. So I'm putting here length, weight, invoice, and energy size. Engine size, and then let me run this. You can see the same thing, your number of observation, mean, standard deviation, minimum, maximum. All these statistics are there for 4 variables. Okay. So what if you don't need all the statistics? You only need minimum, maximum, or a combination of this, or maybe 2 or 3 statistics at one time. Okay, I just want minimum and maximum, nothing else. So why do I do that? Okay, so proc means data, and then your data name, and then at the right of it, just put maximum and minimum. Okay, and how do you know this? If it is blue, if it's a different color, it's not black, that means it's a keyword. So minimum, maximum, you just put there and just run. And in the output, we'll have only minimum and maximum, nothing else. As you can see, for length, we only have the minimum and maximum, nothing else. So that's important. For example, if I need only mean or standard,
We zijn met z'n allen tegelijk lekker bezig. Daarom heb je met Smart Wifi van Ziggo altijd en overal in huis of op de zaak perfecte wifi. Video bellen, video gamen, video kijken. Het kan allemaal op ons krachtige giganet. Ziggo, enjoy it all.
Division. So what I can do? So I'll write mean here and then standard deviation, and then I'll run it. So in the output I have only mean and standard deviation. And you can put as many variables as possible. Probably there is a limit, but you can go on to 30, 40, 50, any number of variables in the var statement. So there is another thing that we can do with proc-mix. We can also get to know the count of missing data, like how many observations are having missing values. Okay, we can count it. How do we do that? In the proc-mix, we can use nmiss, and we can do that. So the syntax is like this: proc-mix data, and then the data name, and then write nmiss, nmiss. Okay, so I'm putting all the variables, all the 4 variables, and let's run this. In the output, you can see the number of misses or the number of the missing values. Well, in our data there is no missing value, so it 0 for all the variables. If you have a missing value, then it will give you how many observations in that particular value are missing. Okay. So to know the missing value even in character variables, we can use proc-mix. So that is not an issue. But for mean, standard deviation, having character variable won't make sense. So don't use mean, standard deviation for character variables. But you can always use character variables. Even I mean, if you want to know the count of the missing values. Now we will see that how do we do data exploration using proc frequency. So what is a frequency? Frequency is nothing but the count for each categories. So basically frequency is something that we are interested to know for a categorical variable. Okay. So for a categorical variable, of course standard deviation or mean won't make any sense. So we just need to see what is the count of each categories. Okay. So make is a categorical variable. So let's run. So the syntax is like this: proc frec, then data, and then you put your data name, table, and then your variable name. Okay. Let's run this. See, so you have the different make and their corresponding frequencies. Okay. So you can count what is the highest number of frequency, what is the lowest number of frequency, and what is the corresponding percentage. You have the cumulative frequency at the right of it and the cumulative percentage at the extreme right. Okay. Well, proc frequency helps us in many ways. Okay. So say for example, the requirement is that we need to have a uniform frequency across all categories. We cannot afford to have just too many observations of one category and then too less observation of another category. Or at least they should be similar, or there should not be a great deviation, or there is a great difference between the number of count or the number of frequency between two categories or different categories. and that's a requirement in many modeling exercises. So we'll get to know that by doing a prop frequency. So as you can see, you have the prop frequency for all the categories, and then based on this, you can take the call, like whether you want to include some more observation, or you just want to leave out some of the categories which are either having very low frequency or very high frequency. Okay.
Je décalais, je esquive. Qu'est-ce que tu deviens cosmopolite? Qu'est-ce que je deviens cosmopolite?
So prop frequency can also be used for doing 2 by 2 cross tabulation, or 2 by 2 cross tabulation, even 3 by 3 cross tabulations. Okay, let's do the 2 by 2 cross tabulation first. So syntax remains same. So origin and time are the two variables where we want to do a 2 by 2 cross tabulations. Okay, so the syntax is like this: origin, then you put a cross mark, and then you put another variable which is type. Let's run this. So as you can see, you have origin in the column, in the rows, and type in the column. So in Asia, how many hybrids are there? Only 3. In Asia, how many SUVs are there? 25. So in Europe, how many hybrids are there? 0. So that's the way in which you interpret a 2 by 2 cross tabulated matrix. So again, this also helps knowing the distribution of the data, how the data is distributed across different categories, and you can take two variables at the same time to get an idea about how is the distribution look like. For example, in Europe, how many sedans are there? 78. So that's quite huge. Similarly, in US, how many sedans are there? 90. Okay, so somebody asks you what is the distribution of sedan across different origin, and then you can answer it very easily. So you have 94 in Asia, 78 in Europe, and 90 in the US. So somebody may ask you, okay, give me an idea about how different type of vehicles are distributed across the in the US market. So you can say in US we have no hybrid, we have 25 SUV, 90 sedan, 9 sports vehicle, 16 trucks, and 7 wagon. And you have the corresponding totals of the subcategories at the right of it. That means in Asia you have 158 variables in total distributed across different types. So similarly in Europe you have 123, in US you have 147. Similarly across the origins, how the different type of vehicles are distributed, you have 3 vehicles in total for hybrid across all the origins, 60 SUVs across all the origins, 262 sedans, 49 sports, 24 trucks, 30 wagon. Now this helps in modeling exercises as well. You probably may not want to have a category which is sort of very different from the other categories. It's having, say for example 94 sedan ACR 94. You probably may not want to have it because it's not very different from other data sets or observations, but you might encounter cases where the category is entirely different from the rest of the category. So that is an outlier. You probably may want to leave that from the modeling exercise.
Bij ING maken we beleggen toegankelijk en begrijpelijk. Zo heb je alles in de hand. Nou ja, je bankzaken dan.
So the next thing is that how do we plot variables and why do we need to plot a variable? Okay, so we can plot a variable by using proc zplot. Okay, so while using proc zplot, make sure that you use the ODA statement. This is a prerequisite. ODA's graphics on. So your graphical features of the SAS program is enabled by when you run this particular code, and then underneath you write a code proc zplot data name. Then you can plot two variables at one time, right? You cannot just plot one variable. So plot two variables. I am plotting length versus weight. Okay, and then let's see how it looks. So you can see in your x-axis you have weight, and then in your y-axis you have only length. Okay, so this plotting is the best way of getting to know your outliers. In fact, when we plot a variable, we get to know about this variable a lot better than having different statistics, because when we visualize the data, it is better to understand it, or you can understand it in a default fashion, and you can get to know which are data points are your outliers, which are not similar to your most of the data sets, which are very different. Just like these points, the points at the very rightmost part of the plot, these points can be considered as outliers because they don't really lie close to your average data. But you can see a lot of data are actually clustered from weight 3000 to weight 6000. Okay, so this is a normal data. Probably you may want to get rid of the data sets which are lying greater than 6000, weight 6000, and then greater than length 220. So all these data sets probably can be considered as outliers, and you may want to remove them from the data sets before doing modeling. Okay. It also helps to know how length and weights are related. You can see that as the length increases, the weight also increases. So we can find that length and weight are very linearly related. If the length increases, so is the weight. Okay. So this is a way in which you can also get to know how the variables are related, whether they are related in a direct way or indirect way, positive way or a negative way. Okay, so a lot of questions can be answered by looking at the graphical plots. Okay, so this is how you do the exploration using graphs. And yeah, so the next thing that we will study is how do we explore data using proc univariate. Okay, so in proc
Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words.
Univariate, we can obviously use one variable at one time. The name univariate suggests that univariate means only one variable. So you can put proc. You can put ODS graphics on, because you have some graphs that actually come out of this proc. So you get to see them. but that's optional. It's not compulsory. I mean, you may not you can remove this also. It's not very important. So the syntax is like this: proc univariate data. You give your data set name, and then which variable you want to explore in the where statement, and then run and then quit. Make sure you put quit in both in gplot as well as in univariate. Otherwise, it will keep on running forever. So proc univariate actually gives you most of the things that you actually get in proc means. Proc univariate is more exhaustive. It gives you the details, a lot more detail statistics about the variable. You have the number of observations, the mean, the standard deviation, the skewness, and then some of the weights, everything is there. Most of these important statistics about the data set is available in the output of proc univariate. You need to know what is skewness, what is cortosic. In proc means it's not possible to have skewness and cortosis in your output. So how does it help? If you know skewness and cortosis, you get to know whether your data set is symmetric or unsymmetric. So what is skewness, what is cortosis, what is symmetric, non-symmetric data, all that we'll study in a different video. So I suggest that you read, you go through that video first before actually seeing this video, so that you will get an idea about the different the statistical concepts before actually interpreting this statistics. So you have mean, median, mode in the output as well. Range is also there. So range is nothing but the difference between your minimum and maximum. You have variance, standard deviation. Variance is nothing but the square root of standard deviation. And then there is a null hypothesis test that is also there. So what is hypothesis test is something that you will learn in a different lecture. So essentially this is the test to know whether your mean is 0 or equal to 0. Well, you have different statistics, and then the p-value and the t-value suggests that the mean is not equivalent to 0. We accept the alternative hypothesis that it's not 0, your mean is not 0. Okay, so that's a very useful thing. You don't need to do it separately. You get it directly from the output. Then there is a very important thing, the quartile distribution. Okay, so this is very important. You get to know.
For just $67, you can make as many videos as you want, and you never need to pick up a camera or use any fancy editing software. With Doodly, you drag, you drop, you tweak some settings, and boom, video done.
What is the value in the first quartile, the second quartile, and the third? Of course, your second is your median, and then your third quartile, and what is the maximum. This helps us also knowing how your data set is distributed, whether it's evenly distributed or there is a very non-symmetric distribution, in the sense that it's very skewed, or a lot of observations are concentrated at one particular area and the very few observations are located at other area. So as you can see, our data is quite evenly distributed, in the sense that it goes from the minimum to maximum at a very fairly uniform way. Sometimes you may come across data set where it could be very uneven. Okay, it starts with a small value, then suddenly jumps, and then doesn't increase much, and then suddenly increase again. So that's quite uneven distributions. And then you have details about the extreme observations. This particular matrix helps you locating your outliers also. So you have lowest, your value, and then how many observations are there. You have highest, the corresponding value, and the number of observations there or around it. So it really helps us knowing outliers, and then we can take necessary steps, like necessary measures. Sorry. So the last thing in the lecture is how do we plot a histogram using proc univariate. So to plot a histogram, we need to use the ODS graphic statement. Okay, so make sure you have it before using proc univariate. So the syntax is pretty much same, just that you have to put histogram and then the variable for which you want to plot your histogram. Let's run this. It takes time. Yes. So, so this is the histogram. This is a graphical plot of the data. So what is a histogram? It's one way of presenting your data in a graphical form.
Ooh la la. It smells like a man.
You have different value of the data in your x-axis and the corresponding count in the y-axis. Okay. And how does histogram helps us knowing data set? It helps us knowing the distribution of data across different values. There is another important thing which is very, very important in statistical analysis. Most of the statistical analysis assumes that your continuous variable is distributed normally, or the normality is a basic criteria. Just by looking at the histogram also, you can get to know whether data set is normally distributed or not. You can obviously plot your normal plot, theoretical normal plot along with histogram. We'll see that in another video. But yes, it looks like it is normal distributed, although it's not a proper way of looking at it. There are better ways of doing it, but it gives you some idea whether it's close to normal or not. Okay, whether it looks like a bell-shaped curve or not. So it doesn't give you a good way of looking at it, but it gives you some way. I mean, in most cases, if you don't have good features in your system, histogram is also good enough to know whether your data set is distributed normally or not. So in that way, histogram really helps us understanding the data better. So to summarize, exploratory data analysis is a must thing before doing any statistical analysis. The techniques are very simple but very powerful and gives us a number of insights which can be confirmed after doing the modeling, but the initial understanding about the data is what we can get by exploring the data more and more before doing any statistical modeling. We can form a lot of hypotheses by looking at the data. Okay, so it gives us an idea, understanding the problem, understanding the data. How do we deal with missing value? What is the count of missing value? whether my data has outliers or not, whether my data is symmetric or unsymmetric, whether my data is correctly distributed across different categories or not. So all these things we can get to know, and thereby understanding the data better by doing these exercises. Okay. See you in the next lecture. Thanks.